Hello and welcome to this video on analyzing operations. I want to try to figure out the properties of a particular operation, in this case an operation star on the real numbers given by x star y is equal to x plus 2y minus xy. And by analyze the operation, I mean first of all check that it really is an operation, and then see, assuming that it is, whether the operation is commutative, whether it's associative, whether there's an identity element in R for the operation, and if that's the case, whether there are inverses in R with respect to the operation. So first, let's say why this really is an operation. X star y needs to be uniquely defined for every pair of real numbers x and y. Well, first of all, if you take two real numbers and star them together this way, the result is a real number. So the real numbers are closed under the operation, and that's good. Also, there's no problem. There aren't any real numbers we're not allowed to star together. We don't have any problems like dividing by 0 here. And also, this completely determines what the output should be given two real numbers. There's no ambiguity here. So yes, star really is an operation. Now that we know that, let's go ahead and see if this operation is commutative. Commutative means if we take any two real numbers, x and y, and we star them together in one direction, x star y, we better get the same thing as we get when we star them together in the other direction, y star x. So let's just see what each of these are for an arbitrary x and y. Well, x star y, we actually have that. We can just rewrite it again. That's x plus 2y minus xy. On the other hand, y star x is y plus 2x minus yx. Now, yx is the same as xy, so we're subtracting the same thing here. The problem is these do not look the same here. X plus 2y is probably not the same as y plus 2x. To be sure of this, let's actually try to think of a counterexample. Let's just say x is 1 and y is 2. Well, 1 star 2 would be 1 plus 2 times 2, that's 4, minus 2. So 1 plus 4 is 5, minus 2 is 3. But 2 star 1 would be 2 plus 2, that's 4, minus 2 is only 2. And 3 is not equal to 2, so we see that this operation is in fact not commutative. Okay, well, let's check the next property, and that is associativity. To check associativity, we need it to be the case that grouping three elements in different ways, x star y, and doing that first, and then starring that together with z, we want that to be the same as first doing x and starring that with the result of y star z. So in fact, we're actually first computing y star z and then taking that starred together with x. Notice we're not changing the order of these elements, just the order in which we're combining a pair of them. Let's see what we get. So x star y is x plus 2y minus xy, and that's a real number, so we can take that real number and star it with z. And if we do that, we get, let's see, the rule says you take the first one and write that down, so that's x plus 2y minus xy. You add 2 times the second of the two things that you're starring together. So we're going to add 2z, and then you subtract from that the product of the two things. So in this case, that is x plus 2y minus xy all times z. Question is, do we get the same thing when we combine these in a different order? Now we're going to do x star the result of starring together y and z. That will be y plus 2z minus yz. And if we write this out further, we're going to have x, the first one, plus 2 times the second one, 2 times in this case, y plus 2z minus yz, and then minus the product of these two, which would be x times y plus 2z minus yz. And the question is, are those the same? You know what, maybe they are the same. Maybe we need to multiply these out all the way and see what we get. I'm not going to actually write this all out. I'm running out of room. If you do so, you will find that there are some differences. We think because we did this out symbolically that these things are not equal, so that means we should be able to find a counterexample with 3 real numbers where these two things don't come out equal. So let's just give that a try. Let's try 1 star 2, then starred with 3, and compare that to 1 star the result of 2 star 3. So let's see. 1 star 2, 1 plus 4 minus 2. I believe we already said that that is 3, so we're doing 3 star 3. And 3 star 3 would be 3 plus 6, that's 9, minus 9. So this will be 0. On the other hand, 1 star, 2 star 3, this is going to be 1 star. Now we have to do the result of 2 star 3. 2 star 3 is 2 plus 6 minus 6, so that's 2. And 1 star 2 we already saw was 3. 0 is not equal to 3, so there we know for sure this operation is not associative. All right, let's see if there's an identity for this operation. An identity for this operation would be an element e such that x star e would be equal to x. Now x star e, if we just write that out for what that is, that would be x plus 2e minus xe. We want this to be equal to x. Is there any e we could choose that would make that happen? Well, one thing you could do is try to solve for e. And if we do that, let's see, subtract x from both sides, and then maybe factor out the e, we would get that e times 2 minus x is equal to 0. Well, this is promising. E could be 0. In fact, if there is an identity element, e would have to be equal to 0. Notice e cannot change depending on what x is. It needs to work for all x. So e equals 0 looks like it's the identity element. But we have to be careful. Because this operation is not commutative, we also need to check, is e star x equal to x? If there is an identity element, e, it is 0. So we would have to have 0 star x equal to x. Star x equal to x. Well, 0 star x is 0 plus 2x minus 0x, which is 2x. So we see that 0 in fact is not the identity. In fact, there is no identity element. What about inverses? Well, if there's no identity, it doesn't even make sense to ask about inverses. So there is no inverse. There are not inverses in R with respect to star for this operation either. All right, and there you have it. Thanks for watching. Hope this has helped.